All right, welcome back to 9.6, the last section of Unit 9. And we are going to be looking at double angle identities. And these identities are really just a special case of the sum and the sum identities, okay? So what do I mean by that? Well, first of all, double angle identity simply means 2 theta, right? So double. So not just theta, but 2 theta. So sine 2 theta, tangent 2 theta, and cosine 2 theta. Notice how you actually have 3 different forms for cosine 2 theta. Again, they're all equivalent. It's just written differently. Sometimes one is better to use than the other ones, and that's usually where students get confused, is to decide whether which one is the right one to use. Okay. Tangent 2 theta, as you might have imagined, is really just sine 2 theta divided by cosine 2 theta. And if you go 2 sine theta cosine theta divided by cosine squared minus sine squared, you actually get this. Okay, so tangent 2 theta, again, just like the sum and difference identities, tangent is simply just sine divided by cosine. Now, what do I mean by special case of sum and sum identities? Well, sine 2 theta, you can simply think this as theta plus theta, right? So theta plus theta is 2 theta. And if you apply, now this is the sum, right? So if you apply the sum identity formula, then you actually get 2 sine theta cosine theta. Same thing with cosine 2 theta, okay? So that's why I said the double angle identities are really just a special case of the sum identities. Okay, so we're going to look at some examples here. Given angle alpha in standard position with its terminal arm in quadrant 4, and that sine alpha is equal to -3/4, we're looking to determine the exact value of these trig ratios. Okay, so we're looking for sine 2 alpha and tangent 2 alpha. Okay, so right away, I know this is sine 2 alpha, which means I can rewrite this. Okay, so right now we can't do anything because that's 2 alpha and that's alpha. They're 2 different angles. However, I can write sine 2 alpha as 2 sine alpha cosine alpha, right? Then you can see this is just angle alpha. Okay, so now from here, I simply need to draw out my triangle. Sine is opposite of hypotenuse, so that's 3, and this is 5. And based on Pythagorean theorem, this will be 4. It's a 3, 4, 5 triangle. And now I can actually find the ratio for sine alpha. Actually, I don't need to find the ratio for sine alpha, it's already given. But I can use this triangle to find the ratio for cosine alpha. Now recall, cosine is adjacent over hypotenuse, so it's going to be 4/5. And cosine in the 4th quadrant is positive, so therefore we leave it as 4/5. And now we just need to multiply. So that's 2 times 3 times 4, that's 24. So -24 divided by 25. And that is your final answer. Okay. Part B, similarly, again, you just need to take this identity and apply right here. Okay, so tangent alpha is equal to 2 tangent alpha divided by 1 minus tangent squared alpha. Okay, we have our triangle done here already, so then we can, again, just use the triangle. Tangent is opposite of adjacent, so that's 3/4. Remember, here's the reference angle, or here's the reference angle. Now, tangent is negative in the 4th quadrant, so I'm going to put a negative sign there. 1 minus -3/4 squared. Okay, and now I just need to evaluate this. This is going to be -3/2 divided by 1 minus 9/16. Okay, now I just need to do some simplification. This is division, again, which means multiply by the reciprocal. I know 1 is equivalent to 16/16. So the denominator will go to the numerator, and then 16 minus 9 is 7. And now, there you go. So it's going to be multiplying by 16/7 instead. And if you just reduce this a little bit here, divide by 2, that gives you -24/7. And that is your final answer. Okay, so hopefully not too difficult for you. Again, given the information, you should be able to draw the triangle, and then we can use that triangle to solve these problems, as we've seen in 9.5. Okay, example 2, write each expression as a single trig ratio and then evaluate where possible. So right now you can see this is cosine squared minus sine squared. So you can see cosine squared minus sine squared is simply cosine 2 theta. Okay, so that is the double angle identity for cosine. So then we can rewrite this as cosine 2 theta. Now, in this case, recall this is the angle theta. That's the angle theta. So we're going to replace theta with pi over 6. And therefore, you end up with cosine of pi over 3. And now we can evaluate this quite easily. Again, here's your special triangle. Pi over 3, pi over 6, 1, 2, root 3. Cosine is adjacent over hypotenuse, so it's going to be 1 over 2. That's it. Okay, cosine is adjacent over hypotenuse. All right, for part B, this is 4 sine 2 theta, cosine 2 theta. So this is actually sine 2 theta identity. Okay, let me rewrite it here. So let me rewrite the sine 2 theta is equal to 2 sine theta cosine theta. You might think, okay, well, they look somewhat the same, but not quite. The overall structure is actually the same, but I mean, we just need to change a couple things, okay? So actually, I'm going to rewrite this this way. So 2 sine theta cosine theta is equal to sine 2 theta. We're just going to compare these, okay? So what we're going to do right now is this start with a 2, okay? But we actually have a 4 here. So what I'm going to do is I'm going to factor a 2 out. Okay, not even 4, just the 2. So then I can make it the same as 2. So then we have 2 times 2 sine 2 theta cosine 2 theta. Now this looks somewhat like the same now, right? Because so what we can do is we can treat this as just like angle theta. And that is just angle theta. So then this is 2 sine theta cosine theta. Okay, but we do have a 2 in the front. So what's going to happen then is we are going to put the 2 in front of this sine 2 theta, because really we can make this look like the same as this. Or I should say the other way around. We can make this to look like that by simply multiplying by 2. So if I multiply by 2, I'll show you. If I multiply this by 2, I get 2. And then I have 2 sine theta cosine theta. But because I multiply the left-hand side by 2, I got to multiply the right-hand side by 2. Right? And that's why I have this 2 right here. Okay? And then I'm going to have sine 2 theta. Now, if you notice, this is angle theta. That's angle theta. Therefore, our angle theta are, again, these two. So it's going to be 2 sine 2 theta, like this. And then if we just multiply the 2 with the 2 theta, you should get 2 times sine 4 theta. And that is how you simplify this. Okay, so again, I need to make 4 to be a 2 first. So I factor the 2. And I know that these two are simply my angles. So then that's my angle theta. So then I replace this angle theta with 2 theta instead. Okay, so this could be a little bit tricky, okay, because you kind of want to make it the same, but they are not quite the same. Here's 2 practice questions for you to try, okay? Give it a try and I'll show you the answer in a bit, okay? All right, so here we go. Hopefully this is what you got. So again, we have sine 2 theta is equal to 2 sine theta cosine theta. Okay, now notice though, this is 1/2. Okay, so not quite the same. So what we need to do is, if we divide this by 4, then it becomes 1/2. So then again, if we divide this by 4, then we gotta divide this by 4. So this is gonna be 1/4 sine 2 theta. Now, except theta in this case is pi over 4. So then we just put pi over 4 in there instead. Okay, you see what I did? Okay, so again, I'm making this identity to look like what we're trying to simplify here. So that was 1/2, but this was a 2. So to make it 1/2, I got to divide both sides by 4. Okay, so then this is 1/4, a quarter, sine 2 times pi over 4 is pi over 2. And we know that pi over 2, or sorry, we know that sine of pi over 2 is simply 1. So, because at pi over 2, the y values is 1. Okay, so there you go. So it is simply just 1/4. Okay, now for part B, this is the cosine 2 theta identity. Cosine 2 theta, recall it was 1 minus 2 sine square theta. Let me just double check. Again, there you go. Cosine 2 theta is 1 minus 2 sine square theta. So then again, I need to make it the same as this, which means if I multiply this by 8, then I get 8 minus 16. Okay, so what I need to do then is this is going to equal to 8 cos 2 theta. Now, again, this case, theta is 2x. So there we go. And then you just need to multiply them together. Cosine 2 times 2 is 4. So you got 8 cosine 4x. Here's your final answer. Okay. All right, so these are the simplifying. Again, this could or expressed as a single trig ratio. They could be confusing, kind of tricky at first. Just do a couple. Hopefully, you'll get used to it. Okay. All right, here we go. We'll do some proofs as the same as in the past. Okay, so here we go. Again, I think I show you some tricks. Again, the first step is always look for the more complex side and change that side. Okay, so right now I see the left hand side being more complex, so that's the one I'm going to change. Sine 2x, that's the identity we just learned. Sine 2x is same thing as 2 sine x, cosine x, divided by cosine 2x plus sine squared x. Okay, now here is the problem. For cosine 2x, we have 3 of them. Okay, right? There are 3 cosine 2x that we can actually use. Which is the one to use for us in this case? Well, what you need to do is you got to look at the rest of the expression. Okay, so the rest of the expression in the denominator is that we have plus sine squared x. So if you think about this, if I use this, if I pick the first one, I mean, let me be straight though. Let me be clear. Okay, you could actually pick any one of those. It's just that if you pick the right one, you'll save you some time. Okay, I mean, if you pick the first one, the problem being using the first one is then, well, actually the first one would be okay too, because we have cosine squared minus sine squared, and then plus sine squared. So what happened then is the sine squared will just cancel out. Okay, the only one I would not pick really is the second one, because it gives us cosine squared, which, I mean, but I got sine squared here, right? So it's there. You could pick that one, but then it's gonna take you more time. I wouldn't mind pick the last one either, because it has the sine squared, which again will cancel out the sine squared nicely here. But I think the first one would be the best one to use, because we have cosine squared x minus sine squared x, and then right away plus sine squared x. So then you can see these two will simply just cancel out. So then what we end up with is 2 sine x cosine x, cosine x divided by cosine squared x, and now we can see we can cancel out one of the cosine x, so we end up with 2 sine x over cosine x. It's because I run out of room on the left, so I'm just going to change the right hand side, because we know sine over cosine is tangent. But that means I can change tangent to sine x over cosine x, and therefore they are the same. Okay. All right. On the right, here we have 2 divided by 1 plus cosine squared, and we also have secant squared. So what I would do is I would actually change secant squared first to 1 over cosine squared x. Okay, and now on the left hand side, again, I got cosine 2x, so I need to change something. Again, we have 3 of them. Which one is the one to pick? Now notice we have 1 here, and we don't have a 1 on the right. So the goal is to get rid of this 1. And hopefully that comes with cosine squared x. And indeed, if you go back, that's the one we want to use right here. Okay, because we had a 1 in the front, and if we put the minus 1 there, well, then guess what? They will just cancel out. Okay, so that's the one we're going to use. Cosine 2 theta is 2 cosine squared minus 1. So 2 cosine squared x minus 1. And again, the 1 plus negative 1 will simply cancel each other out, and all we left with is 2 cosine squared x in the denominator, and the 2 will cancel out. So you end up with 1 over cosine squared x, and they are indeed the same. Okay, that's it. Okay, so there are 2 here for you to practice, and I'll show you the answer in a bit. Okay, good luck. Okay, so for this one here, these 2 actually, again, when you do proofs, let me just be clear. There are actually many different ways to prove. There is no one correct way. For example, in this case, you could change tangent to sine over cosine. okay, and then tangent squared to sine squared over cosine squared, and then you do your fraction thingy and divide the fraction and manipulate whatnot, you should end up with sine 2x. However, if you notice 1 plus tangent squared from the Pythagorean identity, 1 plus tangent squared is actually equal to secant squared. Okay, so this is what I'm going to do actually. Okay, 2 tangent, I'm still going to change that though. 2 tangent is 2 sine x over cosine x. Now again, divided by 1 plus tangent squared is actually secant squared. Okay, so now I'm actually going to simplify this. Secant squared, remember, is 1 over cosine. And now because it's divided by, so instead of times 1 over cosine, it's going to be cosine squared over 1. And then you can see you can cancel out the cosine x. You end up with 2 sine x cosine x, which is simply sine 2x. And you can see they are the same thing. Okay, so that's what you can do. Once you see 1 plus tangent squared, that is definitely secant squared x. Okay, you can reduce that first. Okay, part B, similarity. Okay, similarity. Again, you can rewrite 1 plus tangent squared as secant squared x. That's not a problem at all. This one though, I'm gonna show you. What if you don't recognize that? Okay, so I'll show you. You can still do this question without recognizing that 1 plus tangent squared is secant squared. No, I think this might be. It might take a little bit longer though. However, okay. So what I'm gonna do is I'm gonna stick to my my first rule is to change everything to in terms of sine and cosine. Okay, so I see tangent squared. So I know that tangent squared is sine squared over cosine squared. And therefore, I'm going to change 1 to be cosine squared over cosine squared. So then I have the same denominator. Okay, sine squared over cosine squared. All over, same thing, 1 plus tangent squared, that is going to be sine squared over cosine squared. So instead of 1, I'm going to write cosine squared over cosine squared plus sine squared over cosine squared. Okay, and now because I'm dividing, so now I'm going to flip them. So this is going to be cosine squared divided, minus sine squared x divided by cosine squared x times, now recall, if we are dividing, we are simply going to move the denominator to the top. So then there goes my cosine squared on the top. And in the denominator, I would end up with cosine squared x plus sine squared x. Now these two will cancel out, right? We know that cosine squared plus sine squared x is simply just going to be 1. And therefore, all we're left with is cosine squared x minus sine squared x, which is cosine 2x. And there you go, you're finished. Okay, so notice how in this example, or this practice question, I didn't change 1 plus tangent squared to be secant squared. And that's okay, okay? You can just simply change to sine over cosine, and you can still actually do it. Okay, it might take a little bit longer though. Actually, in this case, it might be similar. Okay, here we go, last example, and then the practice question for you to do. Okay, so it says solve the equation 4 sine squared x plus 4 cosine 2x minus 1 equals 0. Okay, so right away I notice that this is sine and that's cosine. Again, I can't do this question unless I change everything to either sine or cosine. Well, in this case, what I need to do is I need to change cosine to x. Okay, I need to change this one here. And which one do I change it to? Well, because that one is sine, so it doesn't make any sense if I change it to the one with cosine x, right? Because I want to be sine. And I recall cosine 2x, it is equal to 1 minus 2 sine squared x. So that's what I'm going to use, okay? So my equation then becomes 4 sine squared x. Oh my goodness. 4 sine squared x plus 4. Now, instead of cosine 2x, I'm going to write it as 1 minus 2 sine squared x. Minus 1 equals 0. Okay, so then we can simplify this a little bit. We got 4 sine squared x plus 4 minus 8 sine squared x minus 1 equals 0. I just distributed. Collect like terms. 4 minus 8 is negative 4 sine negative 4 sine squared x plus 3. Whoops. Plus 3 equals 0. Okay, and then oh wow, okay, and then we just need to solve for sine squared x, right? So move 3 over, that's -3. Divide both sides by -4. And then now we can, now because both are negative, so really it's just positive. And now if I square root both sides, I get sine x equals, remember because we're taking the square root, so it's going to be plus minus. Square root of 3 is root 3, square root of 4 is a 2. So root 3 over 2. This is one of the special triangles, of course, right? Okay, so then again, special triangle, 1, 2, root 3, this is pi over 3, pi over 6. The reference angle, the reference angle is going to be root 3, opposite of hypotenuse, so pi over 3. Okay, and now because we have plus minus, so now we know the answer will be in all 4 quadrants. So your x1 is simply going to be your reference angle. Your x2 is going to be in the second quadrant, so pi minus pi over 3, which is 2 pi over 3. Your third angle is in the third quadrant, so that's pi plus pi over 3, which is 4 pi over 3. Finally, it will be in the fourth quadrant, and that's going to be 2 pi minus pi over 3, which is 5 pi over 3. Okay, so again, I know my answers would be in all 4 quadrants because it says sine could be either positive or negative, which will cover all the quadrants. Okay, that's why we have 4 answers here. And that is within our domain, of course. Okay, so here's the last question for you to try. It's sine 2x, so I think it's obvious which one you need to change it to. Okay, good luck. All right, so this one is actually a rare question where you can actually have both sine and cosine in the same question, and you actually could be able to solve the question here. So again, sine 2x is 2 sine x cosine x plus cosine x equals 0. That's all. You can't change this sine x to cosine x anymore, okay? So we are just going to leave it like that. However, what I notice is that I see cosine x here and cosine x there. So I guess I could factor out cosine x. So then I end up with 2 sine x plus 1 equals 0, which means either cosine x equals 0 or 2 sine x plus 1 equals 0, which means sine x equals -1 over 2, right? Move 1 over, divided by 2, you get -1 out of 2. Okay, so then we can solve these 2 equations. Again, they are both special angles. Cosine x equal to 0. This means this happens at pi over 2 and 3 pi over 2. Okay, again, that's x1 and x2. Okay, it doesn't matter. I'm just going to call x, okay? So again, cosine is the x value, so it happens at pi over 2 and 3 pi over 2 on the, right? That's 90 degrees to 70 degrees. Okay, sine x equals -1/2. Okay, so this, again, is a special triangle. Okay, I'll draw it again. 1, 2, root 3. This is pi over 3. This is pi over 6. The reference angle is opposite of hypotenuse, so that's going to be pi over 6. Now, we know sine x is negative in quadrant 3 and 4. So, my x values would be pi plus pi over 6, which is 7 pi over 6. And then the other one is going to be 2 pi minus pi over 6, which is going to be 11 pi over 6. And there you go. There are your 4 answers. Okay, and that's within this domain. Of course, you can find the general solution by adding the period times n, where n is the n are the integers. All right, that's it. That's the wrap for Unit 9. Probably the most difficult. I don't know. Maybe, maybe not. We'll see. Let me know if you need some help. Okay. Otherwise, do some questions and good luck. See ya.